In other words, this program doesn't do anything useful at all except to demonstrate what is a record and what is a variable that is of a record type, and how do we access the individual component of a variable like that. Oops, missed that part. Here we go. Just so that you can transition from this class to other classes, what we call a record in this class is also called a struct, S-T-R-U-C-T, in C programming, which is also called a class in C++ programming, as well as Java and PHP and Perl. So all of these concepts are related. Okay? The discussion of records and certain types of programming practice will eventually lead to object-oriented programming. We may not be able to get to those topics in this class, but they are all related. Okay, this is basically the starting point of all of those more advanced programming concepts. So now let's go ahead and trace this code, which is going to be just a little bit boring because once we figure out one thing, the rest of the program is really easy to figure out. There's nothing to talk about in the precondition because we don't have a global variable anymore. And the first line is line 12. We invoke the subroutine main, which means we need a return line number to remember that we have to return to post. But I'm not done with allocating the columns yet because I have to remember to allocate columns, not a single one, for D1 this time. But D1 has a type of date. And the date, according to this record definition, has 3 components. So that means we have to allocate exactly 3 columns, in this case, for D1. So D1 is going to take up 3 columns. But how do we label the individual columns? There are several ways to do it. I can use this way to represent this is the year component of D1, this is the month of D1, and this is the day of month of D1. Okay, so let's go ahead and just use this notation, which is something a little bit different from what I use in my other classes. It's equivalent. Okay, there's no practical difference between these. And because each column is unknown, it is a local variable or a component of a local variable. Now I have to put a question mark in each column to represent that they are all uninitialized to begin with. Are we doing okay so far? Okay. So once I have set up the columns, for the subroutine, which is from column B to column E, I can now get into the subroutine. The subroutine doesn't do anything that's really, spectacular. On line 8, it initializes the year component of D1 to 2010, and that's column C. On line 9, it initializes the month portion of D1 to 11, and that's column D. And on line 10, we are initializing column E, the day of month, to 24. And we're done. On line 11, we deallocate everything that was allocated for the subroutine call. And then we go back to post according to return line number, and that's it. That's the entire trace. Are there any questions about this sample program and also the trace associated with the program? This is basically our first trace that has a record in it. Any questions about this one? No questions? Okay. Let's go ahead and write another program to illustrate what you can do with a record before we start to use records in a subroutine and stuff like that. Okay. So we'll go ahead and make a new spreadsheet. And this time we'll do something a little bit more complicated. What we'll do is we'll have, let's go ahead and try to represent a line, a single line in, let's say, on the screen. In order to do that, I have to be able to represent a coordinate. Okay? what is the most traditional way to represent a coordinate in a screen type setting? Well, there are two popular types of coordinate system. One is the XY coordinate. The other one is the polar coordinate. The polar coordinate is not very convenient for a screen because it is based on rotation and also the radius. So in this case, we want an XY coordinate system. That makes it kind of easy. I just need x as an integer, y as an integer, and that's the end of my coordinate definition. Now I want to represent a single line on the screen. Okay. Now a line in mathematics is not the same as a line on the screen, because in mathematics a line is infinite. It stretches out on both ends infinitely. But a line on the screen has a starting point, it has an end as well. So that means if I want to represent a line on the screen, one of the many representations that I can choose from is simply to start, indicate where is the starting point, what is the first point of that line, and what is the type of start in this case? Coord, okay? Because I can reuse coord now for the start, and also the end can also be now a coord. Yep, you just keep using the dots to dig deeper into the structure. Okay, so basically what I want to do, I guess and is not. Are you guys comfortable of using and also as a name of a component, because I use it as a keyword to end the record? No? Okay, that's fine. So I'll do some indentations here. And this time we'll make it slightly more interesting. In other words, we want to start to practice the concept of using a subroutine to access, a structure, okay, to access a record. So what we'll do is we'll say, define the subroutine to initialize a coordinate. Okay, that's all it's going to do. It will have three parameters. One is passed by reference, which is the coordinate to be modified. In this case, I'll call my parameter point, and it has a type of coord. And the next two are passed by values. Basically those are the XY coordinate that I want to put into this coordinate point itself. So it will be x, which is an integer, passing by value y, which is also an integer. Inside the subroutine init coord, I just want the point, which is passed by reference, to have x, this parameter x, as its x coordinate, and have this y to be its y coordinate. Okay. So the way to do that is not very surprising. It is just saying that we want to use the parameter point, but not the entire thing. I want the x component of point to get the value of x as my by-val parameter. I want the y component of point to get the value of parameter y, and that's all I want to do. Okay, and I will even change my init coordinate subroutine name to xy, which means I'm using the xy coordinate to initialize a point. Is that okay so far? Okay. So this time there's a little spin already because point is not a local variable anymore. It is not even passed by value, it is passed by reference. And in the main subroutine, we'll just do it, make one program that is not too complicated. What it will do is it will define a single local variable that is a line. Okay, so I'll just call the variable a line, which is a bad variable name because it doesn't tell me what I'm planning to do with the line. But in this program, there's nothing I'm doing with the line, so a name like this is just fine. Haven't you noticed something about the name of the records at this point? Has anyone noticed any type of pattern? Yep. Yep. the first letter of a record type, the name of a record, is always capitalized. Whereas I always use lowercase to start the name of a parameter or a local variable. This is not required. Okay, no programming language that I know of will enforce this particular standard. But it is an industry standard. When you're defining a type, when you're defining a record, a struct, or a class, you use uppercase, as the first letter. When you define local variables and parameters, you use lowercase to start. You can use uppercase later on and mix it in, but you start with a lowercase character for a variable name. So once I have line, I want to initialize the two components of line. One is start and one is end. So what I want to do is to say invoke init coordinate xy. It expects a point for the first parameter or parameter point itself right here. So what I can do is to specify one component of a line to do that. So I can specify a line dot start to specify parameter point, and in this case I have to use a double-sided arrow because it is passed by reference. Whatever happens to point as a parameter happens to a line dot start automatically. Then I can supply the actual numbers. We'll just say 23 goes to x and 79 goes to y. And define sub. I just want to find out exactly what this does before we make the program any more complicated. And outside of all the definitions, we'll just go ahead and invoke main to start the entire program. Any questions about the code of the program itself at this point? So it looks a little bit more complicated this time, but it really does not have a whole lot of new stuff that we haven't talked about. It does have a combination of new things that we are talking about. In other words, it is mixing in the concept of passing by reference with the concept of records. So we want to find out what it does when we mix those two concepts together. I think most of you already know what it does. We just want to see how it is represented in a trace. Line number, nothing to say about the precondition, and then we want to invoke main on line 20. The return line number is post. So these few items are really easy to set up, basically a standard by now. Now we have to allocate columns for the local variable in main. Main has one single local variable. How many columns is it going to take up? A line as a single local variable will take up how many columns? Well, let's take a look. Okay, what exactly is a line based on its type? It is a line, right? And what is a line? A line is a record, but a line itself has two components. The first component is start, but a start is also of a record type. It is a coord. And now, so we know start itself has an x and a y component, and the same applies to end. It also has an x and a y component. In other words, when it boils down to things that we cannot break down any further, we have four columns. Okay? We cannot break down booleans. We cannot break down integers. We cannot break down a number. Those are things that are basically final. They cannot be broken down into smaller parts anymore. And each one of those will take up one column. Okay? So that means in this case, a line will take up four columns. Within a line, within the four columns, the first two columns will be labeled start because that's the name of the component of the first component of a line or a coord. The second two, the other two, will be labeled end.